kinematic lab, where we get a marble and we launch it using a spoon, and we find the height and the overall distance using Logger Pro. Here is a little free body diagram of it. Over here, you can see we were given some initial parameters. The spoon height, like from where we launched the ball, was 1.4 meters high, and the distance from where the ball landed was 5.5 feet, but we converted that to meters, which got us about 1.67 meters. Here you can see the max height, and here you can see it intersects back at the origin point. And we're considering the launch point origin. Over here in Logger Pro, I'm gonna go ahead and play the video. As we see, we just saw the ball, the parabola of the ball, get launched and hit the ground. Right away, you can see it is an error, because in Logger Pro, the camera was recorded non-parallel to the wall, so the distance got elongated a little bit. We know in real actuality that the distance was 1.4 meters, but in Logger Pro it says 1.5. So for our calculations, we'll be using 1.4 for these. And another error for that can occur is the point of where the dots are located may not match exactly where the ball is, because the ball was moving at a speed fast enough to where it was blurred on camera. So we just had to guesstimate essentially where the best point was. And for the data, as you can see on the data right here, it shows the position, time, and velocity of the X and Y of the ball. The red one is the X. You could tell this because, you know, time's increasing, but it's remaining pretty constant because there's no forward acceleration on the X. Logger Pro it goes up and down a little bit, but for the amount of it, it's about the same. For the Y positioning, it changes, or the Y velocity, it changes because over time there's acceleration, gravity. So as we see, it reaches this arch, it starts coming back down and down and down. The entire time of the project takes about 1 second. We actually started about right here, I believe. You want to move it over?
It's exactly where we started.
Okay, yeah, we started right here at 1.04 seconds, and we end it at 1.96 seconds. So the overall time was about 9.2 seconds, which we will be using that. And from this, we also got our initial X and Y, come back over here. We also got our initial X and Y velocities, as you can see up there. This is slope was 1.13, that's the X, and slope was 1.989, that is the Y. So those are the initial Y and X velocities. We will be using those throughout the calculations improving Logger Pro. We already discussed time. The distance overall that was covered was 1.67 meters, as we discussed. And the resultant vector was 2.29, which I will show you the calculations here now. So here was all the information that was essentially given from Logger Pro. As I discussed, here's the initial Y, as over here. The X final was just the overall distance that went, 1.67 meters. T, 0.92 seconds. The initial velocity for XI, that's supposed to be V, was 1.135. The initial Y velocity was 1.98 meters per second. The resultant vector was 2.29, which we can see the calculations right here. And the overall, the highest Y point was 1.99 meters. And we got that by, in Logger Pro, we could see along the middle, it showed 0.59 from the point of origin. So we just added 0.59 to 1.4, we got 0.99. Theta, we got for the angle it was launched was cos invert times xi over vxi over the vi. So which would just be cosine invert 1.13 over 2.29, which got us about 60.29 degrees. And that was the angle it was launched at.
And here we go. Now we have the kinematics. Now we have velocity is equal to v naught plus a multiplied by t, and that gives you your velocity at any given point. We have change in x here, which is distance, is equal to v naught multiplied by time plus 1/2 at squared. That's the second equation. Third equation is velocity squared is equal to v naught squared plus 2a times multiplied by the change in x, our distance. And now here we are proving this. We are proving max height through equation 1, and this is by the Logger Pro data, by the way, for this left side here. 0 is equal to 1.989 plus negative 9.81 multiplied by 0.2975, which is the time given to us by Logger Pro, which is not equal to actually 0, it's equal to about negative 0.93. On the right side here, when we are doing our own time, trying to make sure it actually works out, we do, to actually get this time here, we do move over that 1.989 on the left side, divide that by gravity, and that'll give you 0.20275. Now when you plug in that number back in, you have 1.989 plus gravity multiplied by this time here, and it actually does equal to 0. And then even as shown here, AT at time equals 0.20275, it has reached the max height. Now proving distance, we have to use the second equation. On this left side here, using the fact that we got from Logger Pro, change in x distance, which should equal 1.676, is equal to 1.135 times 0.92, which just does not work out, as we have found here, when it actually would equal to 1.0442 using Logger Pro's data. Now, actually using the correct data here, we can do 1.676 divided by the time is equal to vxi. And we do that, we get 1.676, divide that by 0.92, vxi is equal to 1.82. And when we actually enter that into the calculator, 1.82 times 0.92 is actually equal to 1.676.